Hello everyone, welcome back to my additional math channel. For today's video lesson, I will share with you the video explaining the turning point, the differentiation or derivative test. So please follow the video and stay focused because this is a very important concept in determining the turning point, maximum point, minimum point, all depends on the values of dy dx or derivative. The changes of the sign of derivative will actually imply the turning point, the type of turning point. Let's get started with the class.
Okay, now, what does the first derivative of a function tell us? Well, if the first derivative of the function is greater than 0, it's positive. So if the slope of the tangent line is positive, then we know the function is what? Increasing, right? We know the function is increasing. Now, when the first derivative of the function is less than 0, is negative. When the slope of the tangent line is negative, we know the function is decreasing, right? So that's just some background information you have to know before we consider these 4 cases. Now, look. First case. We see that we have a critical number, we have a critical point right here, right? Because the first derivative of the function is equal to 0 at this point, right? So therefore we have a critical point. Okay, so the slope of the tangent line at this point is equal to 0. Now, would this critical point give us a local maximum or local minimum, or neither? Let's see. Okay, so in this case, a function goes from increasing to decreasing. Okay, so if a function goes from increasing to decreasing, then visually we can see that the critical point will give us a local maximum, right? Then we have a highest point in this local region, right? Yeah. So, if the graph of a function goes from increasing, where the derivative is greater than 0, where the derivative is positive, to decreasing, where the derivative is less than 0, is negative. So if a graph goes from increasing to decreasing, then we know that critical point will give us a local maximum, right? Just a visual intuition. Now, how about the second case right here? So in this case, we can see that, well, we have a critical point right here where the derivative of the function is equal to 0. Okay? Now look. In this case, the graph goes from decreasing to increasing. So visually, we can see that we have a local minimum at this critical point, right? Yeah. So, if the graph of function goes from decreasing, where the derivative is less than 0, where the first derivative is negative, so it goes from decreasing to increasing where the first derivative is greater than 0, is positive. Okay, now look. If a graph goes from decreasing to increasing, then visually we can see that the critical number, the critical point, will give us a local minimum. Then we have a lowest point in this local region, right? Local minimum. Okay, now, in the third case here, we can see that, now look, we once again have a critical number right here, right? Because as you can see, the graph kind of flattens out momentarily at this point, right? So the slope of the tangent line at this point is equal to 0. So if the first derivative is equal to 0, then we consider this a critical point as well, right? Now in this case, would this critical point give us a local maximum or local minimum, or neither? Let's see, right? So if the graph goes from increasing to increasing, right? So if the first derivative goes from positive to positive. Then what do we have? Then we have nothing, right? Then the critical point is neither a local maximum nor a local minimum, right? Yeah, now how about the fourth case here? Once again, we have a critical point right here where the derivative of function is equal to 0. Now look, in this case, the graph of function goes from decreasing to decreasing, right? So decreasing where the first derivative is less than 0, is negative, to decreasing again where the first derivative is negative, right? So as you can see, if the graph of function goes from decreasing to decreasing, then the critical number is neither a local maximum nor a local minimum, right? So just visual intuition for the first derivative test, right? So we can make a very easy conclusion here. When do we have local extrema? When? We have local extrema when the first derivative changes sign at the critical point. Can you see that? Look, first derivative goes from positive to negative, then we have a local maximum. Now, first derivative goes from negative to positive, see, changes sign, right? Goes from negative to positive, then we have a local minimum, right? See, so whenever the first derivative changes sign, we have local extrema. Okay? Now, what happens when the first derivative doesn't change sign? See, it goes from positive to positive, doesn't change sign, then guess what? Then the critical point is neither a local maximum nor a local minimum. Same here, right? When the first derivative goes from negative to negative, when the first derivative doesn't change sign at the critical point, guess what? The critical point is neither a local maximum nor a local minimum. Okay? Just some easy, quick conclusion here. Whenever the first derivative changes sign, then the critical point will give us a local extrema. Okay? Now, what kind of local extrema? Whether it's local maximum or local minimum, depends on this, right? So if the sign goes from positive to negative, if the graph goes from increasing to decreasing, then we have a local maximum, right? Now, if the sign goes from negative to positive, if the graph goes from decreasing to increasing, then we have a local minimum. That's it.
Alright, that's all for today's video sharing. I really hope that you now have a better understanding of the concept behind dy dx. That's all. Till then, I shall see you in my next video lesson. Bye bye. Have a nice day.